I'm going to go through the quick formative assessment we did on Wednesday the 18th in my honors class. This has got D versus T and a really basic V versus T graph. In the first one here, I cut straight to the chase. I didn't even have to ask you to look at a graph. I just know that a positive velocity means that it's moving forward, and the negative acceleration paired with the positive velocity, opposite signs, mean it's slowing down. Number one, it is moving forward and slowing down. For number two here, a position versus time graph or a distance versus time graph are exactly the same. So if you want, you can even scratch it out like that. This time I need to write D versus T as what kind of graph I have. The D starts me off with don't sleep in class. S is slope, C is curve. And as always, our velocity is the top row here and acceleration is the bottom row. So I look at the slopes here, I can draw a tangent line, and the slope of that tangent line is negative, therefore the velocity is negative, therefore I'm moving backwards. And the curve. The curve, it doesn't matter about the slope at all. All that matters is you're looking at the curve. Is it part of a big bowl, which is up like a bowl, or is it part of a big mountain, down like a mountain? So I don't care that the graph is decreasing. That's not what I'm looking at. This curve would be part of a bowl, and so it's curved up, and that means positive acceleration. So right here, the curve is up. That means my acceleration is positive. And then these two together, because they have opposite signs, mean that it's slowing down. Moving backwards, slowing down. D versus T. Don't sleep in class. Slope and curve. Slope here is negative, so my velocity is negative, so I'm moving backwards. The curve, there is no curve, which means no acceleration, which is saying the same thing as A equals 0, which means constant velocity. Nothing is changing. It's moving backwards, the constant velocity. I can take it a step further. I can actually say what is the velocity here. So the velocity is the slope of this kind of graph. So I'm just going to do the slope y2 minus y1 over x2 minus x1. This is my initial point. This is point number 1. This is my second point, point number 2. Make sure you don't mess these up. It's 3 minus 8 over 4 minus 2, or negative 5 halves, negative 2.5 meters per second. So every second that goes by, it goes down 2.5. Every second that goes by, it goes down 2.5 meters per second. This one, D versus T, starts me off with don't sleep in class, slope and curve. The slope here is a positive slope. All my velocities are positive, which means it's moving forward. The curve, so again, I don't care about the slope or the fact that the entire graph is increasing. I'm only looking at the shape of the curve. And this is part of a mountain, which is down, and that means negative acceleration. So this is down, which means acceleration is negative, and these two having opposite signs let me know that it's slowing down. So this one is moving forward and slowing down. In the last one, it is a V versus T graph. So make sure that you're writing down which kind of graph you have first, because that lets you know which one to, which saying to go with. V starts me off with very young and sassy. Yeah, the Y is Y coordinates, and S is slope. And again, my velocity information is all here. My acceleration information is all here. The Y coordinates are positive. What that means is if these had coordinates labeled, they would all be in the positive Y. So anything, the graph up here are positive Y's. If I had a graph that was beneath the x-axis, down in this region, these would be negative Y's. So my Y coordinates are all positive, so my velocity is positive, so I'm moving forward. slope is positive, so my acceleration is positive, and these two are the same, so it's speeding up.